So on number 1, so what, if I ever give you a piecewise function, what do we have to do to figure out if it's continuous? Set them equal to each other. Where are we going to set them equal to each other? With me, Tatum. With me, Mace. At what? Yeah, but I've got 2 variables here, b and x. Yeah, we want to plug in 2 for x. We're going to go boop, and we're going to go boop. So I'm going to write e to the 2b has to equal 1.5 times 2 plus b. I'm plugging in 2 for my x. Even though I've written b, what am I going to do in my calculator? Yeah, in my y1, I'm going to say e to the 2x. And in my y2, I'm going to say 3, or 1.5 times 2, plus x, which is the same as b. And for these 2 functions to be continuous, they have to be equal. Do these things equal ever per this graph? Can we do a little second trace intersect? And then you want to go close to the intersect, and they want the first curve, you hit enter, second curve, hit enter. Guess doesn't matter. Did anyone get an x value? Joe Bear, did you get a little negative 2.998? Perfect. All right, D it is. I just want to make sure that we felt good setting them equal to each other, plugging in x, finding that intersection. Yeah? Okay, how about this one? Ooh, intermediate value theorem. Did they say, let the function this, the intermediate value theorem applied to f on the interval 12 to 15 guarantees a solution 12 to 15 if to which of the following equations? So what this is saying is between 12 and 15, my y values will need to be between something. So let's go find my y values. What's f of 12? What's f of 15? And this is definitely calculator active. So you could do it from your graph screen or just the home screen. We could say 12 plus the tan of 12 over 5. Oh, don't forget about that minus 10 at the end. Did you get 1.08 for my f of 12? 1.084 because they make us do 3 decimals. And then I'm going to do of 15. And we get a little 4.857. And so that intermediate value theorem is saying, hey, which of the following equations could be a answer, which would mean that it would have to fall in between these 2 y values. Any answers up there? C4 fits between these 2. If we had to write this out about why the intermediate value theorem applies, what word would we have to use? That the function is continuous. We would need to write that if this was not multiple choice. Lobley asked a great question. He goes, 3, it says the graph is shown below on which the intervals, when they say intervals, that's talking from an x to an x value. So this is saying from an x of -1 to an x of 1, not including the values. Even though this looks like a point. This looks like an x comma y, but you guys, this is actually x to x. And I think an arrow might help you see that. And this is saying x to x. So would you guys say that this graph is continuous from -1 all the way to 1? 1 is here. No, we got infinite discontinuity here at like a half. So I disagree with A. How about from 1 to 2? Is the graph continuous? Nope, point discontinuity. How about from 2 to 3? What kind of discontinuity? Jump. 3 to 5. 3 to 5, it is continuous.
I have no idea.
All right, here we go. For what value of G makes this, for what value of K is G? This should be a G. If I wrote a G there, I should write a G here. Oopsies. This should be a G. Boop. For what value of K makes G continuous? What do we have to do every time with continuous? Set them equal to each other. So we got x squared minus 9 over 4x plus 12 has to equal K. Where are they curious? Where should we be plugging in a 3? I'm sorry. Where should we be plugging in a value? What value should we be plugging in for x? -3, because that's where my potential discontinuity is. When I plug in a -3, what would I get? 0 over 0, right? So what do we need to do? Yeah, anytime we get 0 over 0, you guys don't say discontinuous or indeterminable form. We got to factor it. What's that top factor into? You got it. On the bottom, what can I take out? A 4. You got it. Leaving an x plus 3. Anything cancel out now. And we're left with x minus 3 over 4 equals k. What would I do now? Yeah, now we can go plug that -3 in again because we've gotten rid of that hole. What happens when I plug in -3 in now?
-3 halves.
Yeah, -6/4, as Cooper said, is -3 halves, and that's going to be my k value. Is that an answer? Boop. Anytime. Okay, you guys, what do you think's going on? If we've got limits approaching infinity, if I've got limits approaching infinity, what do I have to have? A vertical asymptote, right? What makes a vertical asymptote in my function? The denominator 0. Guys, where are we going to have a vertical asymptote? You got it. So when that denominator is 0, that's going to be when x is 3. I'm a visual person, people. I'm going to go show at x is 3, I've got a vertical asymptote. And all they said is h is defined by this. Which of the following statements must be true? Must. As I approach 3 from the negative side and 3 from the positive side, do we, have to be going towards negative infinity?
No.
That was A. Have to be going, if you, based on this, you might be wondering, because we've got a vertical asymptote here, is this left side going to negative infinity or is it going to positive infinity? If you are curious, like which one, because we can find that out, all you'd have to do is we could say, all right, as I approach 3 from that left-hand side, what could be a number I could plug in that's to the left-hand side of 3? Really close, because we're approaching 3. I agree. Let's try a 2.9. And what you would do to figure out if it's going to positive infinity or negative infinity is if I plugged in a 2.9 to my equation. I don't care what the value is. What's the denominator going to be, positive or negative?
Negative.
Negative. What's the numerator going to be, positive or negative, do you think?
Positive.
Yeah, 2.9 is really close to 3. 3 squared is 9. 9 minus 7 would be positive. So 2.9 minus squared minus 7 is still going to be positive, okay? Now, we know at 3 we've got a vertical asymptote. We know we're either going to negative infinity or infinity. This tells us which one we're going to. Is a positive over a negative? Negative or positive?
Negative.
It's negative. And that's what's telling me from the left-hand side, we are going to negative infinity. So I can get rid of B and D.
Oh.
Yeah. So have I seen this on the actual AP test? Maybe once in a blue moon. This was from AP Calc Classroom, so it is valid, but I just don't think that they really have us plug these numbers in quite very often. But just for practice, I will show you on the right side too. What happens if we approach 3 from the positive side? Give me a number from the positive side of 3 as we approach 3. 3.1. So if I put a 3.1 squared minus 7 over 3.1 minus 3, it would be a what over a what on top in terms of positives and negatives? Yeah, because 3.1 is going to be bigger than 9. So 9 minus 7 is still positive. 3.1 minus 3, still positive. I know I'm approaching a vertical asymptote, and this tells me I will be going in the positive direction. So, okay, it is going to be C, and that's why I'm just not too worried about this skill. Let f be a function such that this is more typical for us to see. Which of the following must be true? As I approach 5 from the negative side, I approach infinity. What's that look like on a picture? What do I have going on? If I approach 5 from the negative side and I'm going to infinity, yeah, I have to have a vertical asymptote if I'm approaching 5 from the negative side and I'm going to infinity. A, B, or C? Yeah, we got to have a vertical asymptote at x is 5. The only difference here is I made that a negative 5. Okay, we did have to amend that. Okay. All right. Which statements are true? They're asking about horizontal and vertical asymptotes. Okay, this is good because we haven't reviewed this yet today. You guys, when they're asking for a horizontal asymptote, what kind of limit are they actually talking about with a horizontal asymptote as x approaches infinity? So as x approaches infinity, Biscuit, those are those 3 rules that I feel like you might be a memorizer on. I was a memorizer on it. What do people remember? If we're looking as x approaches infinity, that's when you compare the biggest exponents. What's the biggest exponent on the top?
1.
Biggest on the bottom?
1.
Okay, so when they match, what's 2x over x going to simplify to be?
2.
Boom, that's my horizontal asymptote. 2 is my horizontal one. Is that an answer?
Yeah, that's
We like 1 because that's what we just figured out. We said as x approaches infinity. Is a horizontal asymptote when x goes to positive and negative infinity? Yeah. So Beck's like, okay, doesn't that make 2 correct too? Do we have a vertical asymptote?
yes.
We sure do. When that denominator is 0, when's that denominator going to equal 0?
-1.
The denominator equals 0 at x equals -1. I dig it. Final answer?
Yeah.
D. Okay, last 2. Here's a function such that the left bound value is less than 6, which is less than the right bound value. Which of the following provides additional info to conclude that there is a value c in that interval from 5 to 7 such that f of c is 6? What's the one word we need, people? We need to be continuous for that intermediate value theorem to apply. And the last one, let f be continuous as a function. Which of the following statements, if true, would guarantee that there's a number in between -2 and 3 such that the y value is 10? What word do we like? Increasing or continuous for that?
Continuous.
We like we like continuous, thank you. And they're saying, hey, between -2, just to let you know, this -2 is the left bound, and then this 3 is the right bound. And they want the y value to be 10. It went between, is 10 between 0 and 20? Or is 10 between 15 and 30? 10 and 20, right? So it's going to be C.